All right, so guys, let's take a look at this next set of questions. As you can see, we're given a sub n is equal to 3, 6, 12, 24, 48. Hopefully that looks familiar. First thing we want to do is identify the common ratio. So what are you going to tell me the common ratio is? 2. R equals 2. Kara, was that you? Did I hear? No. No? Who said 2? Ella said 2. All right, Ella, how did you do it? Okay, so like specifically, did you look from 3 to 6, or did you look from 6 to 12, 12 to 24? Like which one did you key in on? Okay. Okay. So, and honestly, that's what I did too. I was just hoping that maybe Ella would have said, I took 6 and I divided by 3 and got 2. Or I took 12 divided by 6 and I got 2. Or I took 48 divided by 24 and got 2. Any of those would have worked, right? But as long as we recognize that R equals 2, there's a lot of different ways we can get there. All right? Second up, part B, we want to write out the explicit definition. So the explicit definition, we just talked about it. Hopefully you wrote this down. A1 times R raised to the n minus 1. So if we were to write that off to the side here, A1 times R raised to the n minus 1, we can actually do a little bit better than that as we go here. So what is A1 in our sequence? 3 times, what is R again? 2 raised to the n minus 1. So when I multiply here, we're going to call that 6 times, or raised to the n minus 1. Is that how that works? Still no. Still have to follow the order of operations. Not how that's going to work. So the best we've got is 3 times the quantity, 2 raised to the n minus 1 for this particular problem. Okay. Now again, if we had a different A1 or if we had a different R value, then it would look totally different. But again, with A1 being 3 and R equaling 2, then we have it. Next up, we want to then find the 10th term. So using this explicit definition, when it says to find the 10th term, essentially what that's saying is let's let n equal 10, right? So we're going to find a sub 10, and we're going to actually test this out and take 3 times quantity 2 raised to the 10 minus 1. So as we complete this, 3 times 2 to the 9th. So do I multiply first? Is that going to be 6 raised to the 9th? No. Still no. All right, so 2 to the 9th power, how much is that, please? 2 to the 9th, anybody have it? 512, I believe, yeah. And then 3 times 512, what are we going to have? 1536? Yeah. Okay, good. All right, last up, part D, we want to find the recursive definition. All right, now, you might notice that we have not defined the recursive definition yet. Again, if I were to ask you to take out your textbooks, you're not going to find it in there either. So let's think about, again, we already did a problem where we used the recursive definition, but that was more so just because we knew what recursive meant, just kind of big picture. So using that, what are you going to tell me about the recursive definition? If you're trying to find a term, what do you need? We have to know the common ratio, because we're going to multiply by that. But if I wanted to find, say, the 10th term, I better know what? I better know the 9th term, right? Or if I wanted to find the 53rd term, I better know the 52nd term. So the way that we're going to write that is if you're trying to find a sub n, what are we going to do? We're going to take R and multiply it times the previous term. How do you write the previous term? What comes before a sub n? A sub n minus 1. That's your recursive definition. Okay? Now again, this is the way that we want you to think about it. This is the way that you want to utilize it. Could we also think of it this way? If you want to find the next term, you're going to take R times the current term. Would that work as well? Like I said, the one that we have the squiggly line around, that's more common to what we're trying to accomplish, like I said. But they're both true. They both work. Okay? So for our particular example that we have in mind here, the best we can do to adjust this, what is R again, please? 2 times a to the n minus 1. That would be our explicit definition. All right, questions on this? We got it? We understand this one? All right. All right, so guys, on Tuesday, last week, section 9.2, we had the gap problem. This is another one of those gap problems. Now, please don't, completely squiggle this thing out, but we're going to actually do a different gap problem. And the reason is that, again, I just need to change it in the notes. I've put a little sticky note on there for myself like the last 2 or 3 years, and it's probably because it's over Thanksgiving break. I'm always thinking, I'll do this later, and then I never do until right now. Looking at it this morning, this problem, I just don't like it because it has a bunch of fractions in it. Not to say that you couldn't handle fractions. I know that you can handle fractions, but I want you to see this for what it is and not get tripped up over the fact that we have fractions. So instead, let's do this problem. Instead of saying the fourth term of geometric sequence is 125, let's say that the second term is 6. And then we're also given that the fifth term is 162. If that's the case, we want to find the ninth term. We want to find a sub. Okay? So that's one way that we could write it up, but this is probably more along the lines. So we know that the second term is 6. That's A2. We don't know A3, A4, but we do know that A5 is 162. We don't know A6, A7, A8, or A9, but that's the one that we want to find. And this is our big question. All right, so we all remember doing this gap problem on Tuesday, section 9.2. I think that if I'm remembering correctly, that we were going from the fourth term to the 13th term or something like that. All we had to do was find the difference from the fourth term to the 13th, but then what did I have to divide by? The number of terms between the 4th and the 13th, which would be 9 terms, right? So we found the big difference, and then I divided by the number of spaces in between. But remember, that's for an arithmetic sequence, because I'm adding the same common amount here. This is geometric, so it's going to be a little bit different, but the process is relatively similar. We need to figure out R. Again, even with this setup, if I just off to the side said like R equals 8, then this problem would be a piece of cake. By the way, R does not equal 8. Okay? But if we knew what R was equivalent to, then we could fill in whatever we want, going forward, backward, whatever. Okay? So our task has to be finding what R is going to be. The only thing that we have to go on here is that we know that the second term is 6 and the fifth term is 162. Could I find the ratio between the fifth and the second terms? By taking 162 and dividing by 6. We could do that, right? What do we get, 27? Right? If we did that, we get 27, right? Which is kind of helpful. Not completely. R is not 27, by the way. This is incomplete. I have not finalized this answer yet. But if we were jumping 3 terms at a time, like if I wanted to find A8 or A11 or A14 or A17, this would be very helpful to know because we could actually use that. But we're not looking for A8, we're looking for A9. Okay? So what we do have to our advantage is to know that if I'm jumping 3 terms at a time, I'm multiplying by 27. But I'm also multiplying by equivalent increments as we go. So, 7.
No, I was thinking 3 times 7. I mean, 27.
Yeah.
I don't know the answer.
All right. So we've got to think instead, if I'm jumping 3 spaces, I've got to find the cubed root. Okay? So same story here. What we were really focusing on is what is the cube root of 27? It's not 9, no.
What? I thought it was 9.
R is going to equal. So if we know that R is 3. All right, so guys, this, just as much as anything else, the reason why I think we need to talk about this problem is to understand some of us are going to have a cube root button on the calculator. Some of us have that. But in fact, I bet all of us do somewhere. It might be hidden. But we also need to know where the X root button is on your calculator. Okay? Because again, this problem, it just so happened to be that we were jumping 3 spaces. What if we were jumping 4 spaces? You probably don't have a 4th root button on your calculator or an 8th root button on your calculator. But you have an X root button. So if you chose to use the X root button in this particular problem, you would have to type in 3, then you'd hit the X root button, then you type in 27 and hit equals. Guys, did everybody locate the X root button on your calculator? Like I said, depends on which calculator you have. Again, if you're using a scientific calculator, it's really close to the, it's above the caret feature. So again, from the number 7, go left 1, up 1. If you're using a Texas Instrument graphing calculator, go under the math feature. Again, you'll find it down there, very close to your cubing and cube rooting and all that stuff. All right. So back to this problem. Now that we know that r is equal to 3, now we can actually fill in the remainder of this stuff. So if we wanted to fill in all of it, again, if the second term is 6 times 3, the third term is 18 times 3 tells me the fourth term is times 3. Does that confirm that the fifth term is 162? Times 3 is 1458. Times 3 is 4374. And times 3, my answer is 13,122. For a complete list, I'm not going to multiply by 3, but divide by 3 to get that first term is 2. Okay? But again, we were just asked to find the ninth term, and we did it. All right, does everybody see how that problem works? Does everybody see how this is similar to, but definitely not the exact same as gap problems with arithmetic? Okay, again, it's all about finding that common ratio. We get the common ratio, I have no doubt in my mind that you can be very successful finding whichever term you're seeking. All right, last things we want to talk about today are the sum formulas. Starting off with the finite. Okay, starting off with finite, we're going to be given a lot of, within the directions or within, problem to problem, we're going to be given the sigma or the summation notations. Again, I just think that it's important that we recognize that we're actually given a lot of the information just like up front. So as you can see here, our sum formula, we're going to say it's going to be A1, my first term, times the quantity, 1 minus r to the n, over 1 minus r. In order to be successful there, I think that hopefully you all agree that we need to know what is A1, what is r, what is n. So long as I have those pieces, then it's really just plug in and use a formula, right? Which you haven't gotten this far in math if you don't know how to plug in and use a formula, right? I'm very confident that you can do that. What I'm hopeful that we can get to is the realization that if we're given sigma notation, that you're pretty much hand-delivered most of these pieces. If I were to actually try to find the first term, what am I going to let I equal? 1. So if I put a 1 in place here, 1 minus 1 is 0. 0.3 to the 0 is just 1. What's 4 times 1? It's just going to be 4. So are we recognizing the pattern that that's A1 right there? That's it. There's A1. Okay? I bet you've already picked up on the pattern. What's R? Isn't that going to be the base of the exponential? So in this case, 0.3, that's going to be the base. Okay? Now this one's a little bit trickier because there's a catch to it. Works the majority of the time, but not all the time. But what is n? In this case, it's going to be 12. I have to say in this case because we're starting at 1, going to 12. If we were starting at 5 and going to 12, it wouldn't be 12, would it? We'd actually have to go back and figure out. Or even the one that you probably will see, if we were starting at 0, there would actually be 13 terms, not 12. If we were going from 0 to 12, we'd have to count the 0 term, right? But anyway, if we've got A1, R, and N, like I said before, now it's a matter of just plug in. We're going to say that we're going to have the first term, A1, times the quantity, 1 minus R is 0.3, raised to the n, which is 12. This is all over. 1 minus r is 0.3. All right, so like we talked about at the beginning of this lesson, you will need a calculator. A lot of this is going to be done on calculator. What are we obtaining here, please? We want to make sure that all of us are typing this in, because if we're making a calculator error, we want to catch it here and now, not later on. What are we getting, please? 5.714. Anybody landing there? All right, 5.714. All right, so as we glance ahead at the last type of problem, what's the first thing that comes to mind here? That now all of a sudden we're finding the infinite. First reaction when you see this formula. As compared to the last one, what do we think? Shorter, right? Easier. The reason we can't use n, because n is infinity here, isn't it? If we're talking about finding an infinite number of values, this is how we're going to plug it in and find. All right? So guys, again, I promise you, this plugs in directly. Same thing. We have A1 is 4, R is 0.6, and doesn't